problems? Any? Uh, so my plan is to finish everything within this week, and then I'm planning to have some classes outside, paper classes outside physically, and also online. So those who want to join physical classes, you can join or physical or online, and then maybe I think we'll have like 2 weekends to practice papers. And then after the exam, I'll be continuing the classes to finish most of the syllabus before I leave. After leaving, I'll be continuing classes online from there until you guys go to the exam. That's going to be my plan, right? Okay. So procedures. Now, procedures and functions. Those who did O-level computer science, you know what exactly procedures and functions are. These are code blocks. These are independent code blocks. So it's like a small program. If your main program is a big program, it will consist of small programs. Right? You remember decomposition, right? We broke the main problem into small problems. So these small problems can be developed into procedures and functions or modules. And then we collect all these modules and combine it into the whole solution. These modules can also be called subroutines. Subroutines. So these code blocks operate on their own. They take parameters into the uh, block, and then they work with the parameters. Parameters are values, right? And then they produce some kind of output, just like a normal program would do. And they can interact with the main program. They can interact with other subroutines as well. So one subroutine can pass the data or results to another subroutine, just like the structure chart. You saw one module was passing values to another module. In fact, in the structure chart, what we are identifying are the modules or the subroutines. Okay, understand? Pusande, Luto, Netma, Saini,
Yes,
understood?
yes,
Netma, Luto, Saini, did you understand the concept of these subprograms? Yeah, so subprograms can be called subroutines, modules, yeah. And these subprograms can be of two types. One is procedures, the other is functions. Okay. Uh, you have been using these functions and procedures already in Python. For example, we used input, that's a function. We used int, that's a function. We used what? Print, that's a function. So these are subroutines, functions that are already defined, built-in, built-in functions that are already defined and stored in the libraries. If you want, we can also define our own functions, own procedures, own subroutines. So we have built-in functions, built-in subroutines. We have user-defined subroutines. Okay, we are not going to do this in detail. What is required required for this term is that you should know how to write the header of the function, the header of the procedure. Header means just this procedure, procedure name, some statements, and procedure. That's all. Okay, so we are not going to do in detail here, right? So if it is a procedure, you write procedure like this in capital, and then the name of the procedure, and then some statements, whatever you are going to do the program, and then you have to put end procedure. So procedure to end procedure is the module, is the routine. Now that is defining the subroutine. Just defining subroutine is not enough. You have to call. For example, if Busanda is a subroutine, we have to call Busanda to get work done. So how do you call this subroutine or the procedure? Call, right? Use the keyword call and put the name of the subroutine. That's all. Call something. Okay, here's an example. Procedure, stars. Stars is the name of the procedure. It's a procedure. And then you have to use brackets. Okay, now they have missed brackets here. Okay, that's a mistake. You need brackets. So remember input function had brackets. Int had brackets. Print had brackets. So they were all functions or procedures. I'll tell you the difference between the two in a moment. So now you have the brackets. Inside the brackets, you can see they have a variable with a data type. So these are called parameters. Okay. These are called parameters. This is a parameter. Parameter. And this is the data type of the parameter of this. This is the procedure, this is the procedure, and this is the procedure name. Okay. And then you have to put end procedure. Inside that, you have some statements. And this is, of course, this you know, it's a for loop for counter 1 to number. Output asterisk, next counter. So the count is incrementing 1 by 1. Now, what is this number? That number is the parameter. So this parameter comes from outside. Remember in the structure chart, we had like this way. Then we drew like this. What were these? These were parameters. But this parameter was coming out of the module. This is the module, or the subroutine, or the procedure, or the function. Coming out. There were some parameters coming into the module. All right. So this one is coming into the module because it's inside the brackets. And that parameter is used in the for loop to print a number of asterisks according to this for loop. So this will go from 1 to whatever the number that it has. If I'm passing 10 for this number, this for loop is going to go from 1 to 10, printing the asterisk. Incrementing the counter 1 by 1. Understand? Is that clear? Can I see a thumbs up if you understood, or a thumbs down if you didn't understand? Perfect, right? That's it. Okay, so this is defining the procedure. But just defining is not enough. You need to call it. So this is the call, the procedure call. How do you call? Use call and the name of the procedure. Again, something is missing in this book. So there are a lot of mistakes in the book. Right? What is missing here? The brackets. You need the brackets. Right? Inside the brackets, that's what I have corrected here. Inside the brackets, you need to have a value. This value is passed to the function, to the procedure call. Right? So this value will be taken by this parameter number. So if I put 10 here, this 10 will be taken by this number. And then it will be used inside the procedure. So when you pass values to a calling subroutine, which is a procedure or a function, we call them right? They are called arguments. They are called arguments. Simple. So when you call the procedure or the function, we pass arguments. When you define the procedure or the function, we put parameters. So the arguments will be taken by the parameters and used inside. Is that clear?
Yes, sir.
Okay. Anything else? Yeah. Now let me tell you the difference between the procedure and a function. So before that, let me copy this. No, I think it's better we look at the function and then compare. Okay, here's a function. Okay, so when it is a function, that is also subroutine. Okay, that is also uh, a code block. That is also a module. But there are few differences compared to a procedure. First notable difference is instead of procedure, you put function. Then the function name. Again, the bracket is missing here. We should have a pair of brackets here. And then the second difference, you need to have something called returns. Returns. And then a data type. Returns a data type. Why do you have returns and a data type? Because a function will always return the result back to the program which is calling that function. So it's something like this. If Bosandar is a function, if I ask Bosandar to do something, Bosandar should return what he did to me because I am the one who called Bosandar as a function. So he has to return his result, his work back to me. Okay, so function will always have returns and the data type. So why there's a data type? Because the returning value can have a particular data type. The returning value can be a Boolean value, true, false. Then of course it will be returns Boolean. So it is the data type of the returning value. If the function is returning an integer, it will be returns integer. If the function is returning a real number, it will be returns real. Okay, so the differences are you have function here, and then there's a return statement and a data type. And then you have function and function. Simple. Okay, let's look at an example. Here's an example. Right, now remember, even the function can accept parameters. Both the procedure and the function can accept parameters, no problem. and the parameter should be inside the brackets. So here's the function name Celsius. It is accepting a parameter which is temperature, which is of real data type. And after doing something, doing a calculation, it is returning a real number. So returns real. Returns real. What is it going to return? Now you can see inside the function, you should again have the return statement. This one is returns real, that is the data type of the returning value. And here you should have the return statement. So it's going to return the result of this calculation. And why is it real? Because you can see you take you minus 32 from the temperature and divide it by 1.8. So 1.8 is a real number. If you divide an integer by a real number, the answer is also going to be real. So returns real. All right. And as the function name suggests that this is calculating a temperature into, it's converting a temperature into Celsius. That's why they are deducting 32 because Fahrenheit value is larger than Celsius. So you deduct 32 and divide by 1.8 and it returns the Celsius value as a real number. Okay, understood? Up to that point? Thumbs up?
Yes, sir.
Click off, sign in. Look off, sign me. Did you understand? Okay, right, good. Now, the next question is, how do we call the function? Again, you need the function name, then the brackets, and any arguments that you are passing, right? But you can see it's slightly different from the procedure, right? In the procedure, did you see it was just it was just calling. There was no variable or anything, right? It was just calling. But look at the function, right? When you're calling, see, you call by passing an argument, and then there's this part. You can see this is being assigned to a variable called myTemp. So why are they assigning the function call to a variable? Can anyone tell me? Why are they assigning the function call? Function call is here, passing the argument. They are assigning the function call to a variable. Why? Can you tell me why?
Because it can change with the call.
Not really. Okay, the hint is this function does something that procedure didn't do. What is it? I told that if I give a work to Busanga, Busanga has to do something. After completing the work, he has to do something. What is it?
Yes,
Anyone?
return.
Ah, there you go. Return. Others also speak that. Don't worry. Just speak. Doesn't matter if it is wrong. Yeah, the function is returning. Yeah, even no apita. Function ne call karat yeah apita even no. Right? Even no api gando. Right? To hold it, to take it only, we have a variable. So when this is returning the result, we have to hold it in a variable. That's why the function call is assigned to a variable. So it is returning this temperature result, which is supposed to be a Celsius value, and that value gets stored in myTemp. So after that, we can print myTemp. Simple. So we are calling the function by passing one argument. This argument myTemp is going to be the Fahrenheit value. It will be taken by a parameter called temperature. Temperature is used inside to calculate the Celsius value, and it's being returned. That returning value is getting stored in another variable called myTemp. MyTemp can be output. That's it. Okay, so the main differences between the function and the procedure are, instead of in procedure, we have the keyword procedure. In function, we have the keyword function. Both have names, both have brackets. Inside the brackets, they can have parameters, one or two parameters, or one or more parameters. And function will always have this return statement with a variable, data type. And then inside, it will have this return keyword. When you're calling the procedure, you just call it by its name and brackets. You can pass arguments into it. These arguments are taken by the parameter. So if there are two parameters, you have to pass two arguments, and they will be taken in the correct order. In function, when you pass arguments, they will be taken by parameters, and the result will be returned. This returning value has to be stored in a variable before being output. Simple. Okay, got it? Okay, let's do a small exercise, right? Write a procedure and a function to accept two numbers and an output the total. Okay, can you start writing the pseudocode? First procedure. So you can start like this: procedure total or tot, or let's say total. And how many parameters it should take? Two parameters. Num1, which is, let's say, integer, and then comma num2, which is integer. And then inside, you have to write the process between procedure and end procedure. Okay, go ahead. Can you write the procedure and the function for both? So what do you write inside? You can say, since the procedure name is total, I will take answer as tot, right? Tot, arrowhead. You have to use arrowhead, right? Yeah, like this. That's for assignment. Now we have taken two parameters. We can add them together. That's num1 plus num2. Okay, now you must be having a question. If it is a procedure and if it is calculating something, how do we see the output? Didn't you get that question? In the function, of course, we came to know that it is returning the result, right? But if Busanda is a procedure, I will ask Busanda to do something and output without returning the result to me. So if it is outputting, we have to display it, right? We have to print it inside the procedure. That's how it does. So in this example, there was no output. How do you output? What do we use? Display or output? Output, no? This one, output. So what do you do? Output tot. That's it. That's the procedure. But that's defining the procedure now. You have to call the procedure. So how do you call? Call total brackets. Inside the brackets, I need to pass what? What should I pass? Lutov? When you're calling the procedure, what should you pass? Lutov? Okay, so that's a procedure now. So let me show you function. If it is function, the name, again, two parameters, num1, integer, num2, integer. Now the difference. What do you put? Return.
Returns.
That's right. Returns. And what's the data type?
Integer.
Integer. Good. Returns. Do we put a colon? No. Yeah. Returns integer. There you go. And then in function, in between, we write the code. What do you have to do? We are getting two parameters, num1 and num2. So tot
Return.
equals, hold on, tot equals num1 plus num2. And after that only return. It's not printing inside, it's returning. Return tot. Right, now to the call. How do you call? Call function name total. Again, you have to pass two arguments. Right. Remember, just calling is not enough because this is going to be returning a result. Therefore, we have to put it like this. Did they have call there? No. So without call, we'll do like this. We need to have a variable. So we'll call this, to make it different, I will use T, capital T, yeah? T assignment. So the returning value of this function call will be stored in T. Then we had to output. So output T. Otherwise, we won't be able to see the result. That's the difference, right? This is a procedure and this is a function. Understand? Okay. Easy, right? So this is how we write the pseudocode. Okay, understood? Who's on it?
So we
Netma?
put arguments, the total in
Yeah,
T.
we put the
Stop.
we put the arguments in the function call or the procedure call. We put the arguments inside that. Right? So they will be taken in the same order. 54 will be taken by num1, 65 will be taken by num2. Right? So this function call will return this total. That thought gets saved in T, and then we output T. Get it? Understood?
Yes.
Netma? Can I see a thumbs up if you understood? Yeah. Luthov? Luthov, can I see a thumbs up if you, yeah, okay. Now you can't believe anything without seeing it, right? Without seeing it real. So let me quickly code this. So then you will believe this. But remember, in the exam, you are not supposed to code. Okay, first the procedure. We don't use any keyword called procedure. It's def total, and then num1, num2, colon, dot equals num1 plus num2, and then print dot. Okay, just to show you that this is coming from the procedure, I will put procedure comma dot. That's it. That's the definition of the procedure, and then we have to call how do you call by its name total, and then you have to pass two arguments here. Okay, let's see the output. There you go. Okay. Now it confirms, right? It confirms this. That's procedure. Right. Next is function. Okay, I'm going to comment the whole thing and do the function. Again, same method. You don't use any keywords called function, but you use def total brackets num1 comma num2 colon calculate the tot num1 plus num2, and then what do you do? You have to what do you have to do, Luthor? If it is a function, yeah. If it is a function, what do you have to do to the result, Luthor? Netma? Return. Good. Excellent. Return dots. That's it. And then you call function. How do you call the function? By its name, total, pass the values, pass the arguments. Okay, now remember, don't forget that this is returning. When you're calling, it is returning the total. So we need another variable to hold it. So t equals the function call. And then you print t. Print I'll put function t. There you go. Same result, but through the function. Is that clear? Is that clear, everyone? Is it right? Bosanda? Hello?
Yes, sir.
Yeah. Did you understand? Is that clear? Now it's confirmed, right? I showed you the actual output.
Yes, sir.
All
It's
right.
clear.
That's procedures and functions. Not in detail, but I showed you how it should be written in pseudocode, especially the function header and the procedure header. Okay. So once you get the header, the what is needed as the rest is the process inside the procedure or the function. What you do inside that, right? So when they give a question, you have to write the lines of codes in pseudocode. And before doing that, you have to check whether they are asking for a procedure or a function. And accordingly, you can write the header, function header, and the function procedure header. Inside that, it's the same, the normal code. Only difference is if it is a procedure, you know how to write the procedure. If it is a function, you know what needs to be done. Okay. So let's take a few questions I gave you that day. But remember to remind me about trace table and dry run. Function and procedure headers we did today, right? Okay, let's take a few questions. I hope you did the answering. Let's take this one. You have to answer, give your thoughts. Okay. A software company is working on a project to develop a website for a school. Now read these questions carefully. This can be really tricky. Yeah? A software company is working on a project to develop a website for a school. The school principal has some ideas about the appearance of the website, but it is unclear about all the details of the solution. Principal would like to see an initial version of the website. So when they say initial version, what do they refer to? What are they talking about? Initial version? Yeah,
To give an example,
speak. They want a prototype, right?
yeah,
That's why initial version, right? Now, what are the three types of life cycles we learned that are about identify life cycle method that would be appropriate in this case? What are the three life cycles we learned?
the waterfall, iterative, the rapid.
That's right. Waterfall, iterative, incremental, and rapid. I hope that you created a table comparing the features of these three. Then it will be really easy to answer this. So in this case, give a reason for your choice, right? Can we use waterfall method here?
No,
Why?
because he need a prototype.
Exactly. So waterfall method, we can't, I mean, method you can't. What about iteration incremental? Iterative, iterative
Yeah,
increment.
you can use.
Yeah, that produced a prototype. And
Before the
yeah, and there was a lot of user involvement. And this was ideal for a big project, no? Where the initial requirements were not clear, but you have an initial idea. You have an initial idea, you know what you're going to do, the overall project, you know, but you can start straight away. What about rapid?
no, takes too much.
Yeah, rapid was
It this you know
rapid was
rapid is unnecessary for this.
yeah, rapid was good if the project is needed quickly, and there you needed to understand the requirements clearly, right? And the user involvement, what was the user involvement in rapid? How about the user involvement in rapid? It was done in parallel. Yeah, the main feature was
It
it was
was
parallel. Minimal planning, high customer involvement, as customers can use the prototype during development. In this one also, you have prototype development, right? And if it is needed quickly, we can go for rapid. We get the feedback from the customer. And the system has to be a modular one, and also it should be done by a strong team of skilled developers. And it's not suitable for short and simple projects. What is suitable for short and simple projects is waterfall model, right? But in waterfall, there's no customer involvement in the middle. So we can use either this one or this one. Now, are they talking about the time?
no.
Yeah, they're not talking about the time. Therefore, you can go for this. If they want it soon, you can go for this. Okay. In a website, yeah, we can find modular design in a website, because there are pages. We can, identify different sections. So either this one or this one, but depends on what you justify. So let's go for iterative, incremental.
So isn't the rapid is like you make the the planning for that and you divide it to groups?
Yeah, that's right. That's right. That's why it's called parallel, right? It's parallel implementation. A
It would be hard, no? For this one?
website.
Yeah.
Yeah, website might not have like enough modules to be divided among different teams. Like it's a school website. No, school website might be like just an information website,
Yeah.
informative. But if it is an e-commerce website, of course, yes, you can go for this one. And that's why if you say rapid, then time is also a factor. But there is no mention of the time, but you can justify, right? If you go for this one, you can say uh, principal wants to see a prototype, right? Principal wants to See a prototype. Uh, initial uh, initial ideas not are not clear. Therefore, we can get his feedback based on the prototype. Understand?
Yes, sir.
If you say rapid, then you can say, yeah, Lutaf, why do you want to leave? Hey, come on, I'm going to finish it in a moment. In like, it's 12 a.m. Hey, come on, man. You'll have to wake up. I mean, you'll have to stay awake till late night and even early morning when the exams are closer. Okay, so practice that. I'll take another 2 minutes. So if you say rapid, yeah, you can say maybe the school wants the website soon because they're starting a new term, new year. They want the website soon, and um, again, rapid uses prototype. So the custom involvement is there. We can start with an initial plan. We know the overall uh, project is what the overall project is going to be. So we can go for rapid as well, but certainly not waterfall because of this part, right? They want to see the initial version, and also the requirements are not clear. All right, let's take one more question. Just one. Okay, let's take this one. Okay, the website has progress to the design stage. Design stage. Stage 3 activities that will take place during the design stage of the program development lifecycle. That what do you do? Now you have to relate this to the website. You can't just write general answers. What would be the activities in design stage for a website? Yeah. Page layout. Then form design. What else? What about image manipulation? Design? No, not that one. That can be development. Anything else, Bosal? Form design, page layout, sitemap. That is the overall structure like this. Right? Sitemap. Okay. Understand? Any questions?
No, sir.
Lutov, what about you? Right. So we answered two questions. We'll answer the rest of the questions in the next class. So basically now we can start after. Now we have one more, that is dry run and rest. Once that is done, we can do complete papers. Okay, so be ready for that. So I'll see you in the next class. Okay. See you then.
So can you share the scheme of work?
Yeah, sure, sure. Okay, here we go. Done. Okay then. Good night and good morning.
Good night, sir. Thank you. Good morning.